Welcome to another special guest episode here at the Institute for Natural Philosophy. In it, we present Dr. Moore, who is both a Bachelor in Science and a Doctor of Philosophy. He received formal training in medical sciences from the University of Alberta, followed by a Harvard Research Fellowship. His academic work has led to several peer-reviewed publications with over 650 citations. While a fellow, he founded a cloud-based software company with a social network component. In the software industry, Dr. Moore helped establish online services for the healthcare industry and later build a career in the global pharmaceutical industry, eventually becoming head of medical affairs in Canada. During COVID isolation, Dr. Moore made a scientific discovery that serves as a platform for various applications, including multi-celestial timekeeping. He re-examined ancient mathematics and architecture to piece together a geometric system for dimensional analytics. In 2021, he launched a pilot application for a Mars and Lunar timekeeping device for Android, followed by an iOS version in 2023. Leading up to these, he has patent applications and published peer-reviewed articles that extends to conference posters offering novel concepts for modeling time and quantum phenomena. His approach is beginning a path to mathematically formalize the theory of relationalism, introduced by Mohists in China from about 300 BCE, made popular in Europe by Leibniz in the 1700s. This work is building an alternative way to model matter, space, and time. My name is Ricardo Calvario, and I will be your host for this episode. Without further ado, hoping you enjoyed it as much as I did, I give you Dr. Stephen Moore. Today I have with me Stephen Moore, a PhD specialized in mathematics and its relation to the ancient world. And we have lots of questions, and we're hoping to have a very interesting conversation this evening. Thank you very much, Stephen, for coming and for staying with us. Decided to accept this invitation. We are very grateful for your presence. Thank you.
Thank you for the offer. Thank you.
Thank you very much. I would start because most people would not know you. For you, your work is more backstage, as you already told me, writing articles and scientific papers. I would introduce you asking, who is Stephen Moore? Where did his interest begin, and how he saw this vision of connecting mathematics to the ancient world and its culture?
All right. Well, thank you very much. Pleasure to be here. So my name is Stephen Moore. So I have a PhD in science, also been trained at Harvard. So I was in the academic industry for quite some time, but I left that and moved into the corporate world and spent most of my career in that setting rather than studying science. But actually, I took recently, just actually before COVID, I started a startup company and a consulting firm. And so this is introducing how I came into this research. So at that time of starting consulting, right before COVID, not a good time to start a consulting firm because you can't do networking. So, and to translate it, I had a lot of time on my hands. So for me, the lockdown at COVID actually gave me dedicated and solace to study and do research. What happened was I was having lunch. What spawned all this was I was having lunch one day, and in front of the TV, there was an episode talking about ancient architecture, Neolithic stone sites. And they showed an image where they showed a two-dimensional image, an aerial view looking down. And they said, some people believe there's geometry in these sites. And when they showed the circles and the arcs and the dots, I had an immediate recognition of potential ratio between Earth and the moon in those geometric drawings. And I jumped out of my seat and I took a picture of the screen and I just went down into the mathematics of it. And that's where it all started. I started to understand through 1,000,001 iterations, tens of thousands of hours of work to explore the mathematics of these sites and not all sites, all Neolithic sites across the world. I didn't have selection bias of Europe, didn't have selection bias of Asia. I looked at all of them using the same mathematics. And the more I looked, the more it all started to work together, and the more it started supporting each other. So it just kind of became my passion and obsession since then.
Amazing. So it was an eureka moment.
It was a eureka moment. I had no plan. I had no idea that this would happen. And it's been the last 3.5 years of my life, basically.
Okay. So let me see if I can get you to relate your investigation with our current perception in a few words. We believe that the ancient sites, including the Neolithic, were built with a set of tasks. The first task was to find the place that we believe it's due to its telluric energies. The second step would be to choose the right mineralogy, meaning the right stone with the right quartz content, to create upon that telluric nerval center. Then there came the architecture, that is your area, that would study the construction following alignments, but more importantly, the correct shape and form to create the exact resonance that was trying to be obtained through the introduction of sound, or even, as we found in several places, by just the moving of wind, or that is more predominant in certain times of the year. That's why celebrations might be on this date or on that date, because that would have the right conditions. Now, I only have to add to all of this the hydrology, because it was very important on all these sites. They have either underwater ground air, water, and we have even seen some places where the courses of rivers were changed, which is a gigantic task to change the course of a river just to make it to link with the monument that is being built. So what can you add to this through your research?
Yeah, so I see this as different layers of information. So there's nothing in my mathematics that disagrees with that. And actually, a lot of it supports it through physics. And like you said, like, for example, redirecting saltwater and fresh water to different sites helps creating batteries environments as well. And that's being explored in modern applications as we speak. So that is all aligned. Also, the selection of the site, I think, can be looked at not only from the perspective of the energies of the site, which I don't disagree with, but what I see them as is a mathematical alignment based on the construction markers, if you will, the alignments to the summer solstice, etc. Like, for example, unpublished research that I have right now is showing that Stonehenge and the alignment of that site, not only as we see it in the sunrise and summer solstice, but it aligns potentially, the hypothesis based on the mathematics, is that it also aligns to a total solar eclipse of the new moon. So there seems to be layers of information that will all align and come together for these specific sites.
Okay, so would you say that moon eclipse can show us a point in time, or is to several moon eclipse?
Both. So in the mathematics I study, I'm bringing in modern concepts. So one of the modern concepts is called signal processing. So signal processing uses specific discrete signals to mark instances. And so what I think are these astronomical alignments are actually signals that mark a point in time. And once you can mark the signal to a point in time to a specific, like, for example, it allows us to date the sites. The reason why is because if we can find and date back to when at the time of the Stonehenge was there a summer solstice at the same time as a new moon event at that location. That's a mathematical exercise. If you have the right data sets, you can trace that back. And it'd be fascinating if we could trace that back to the dated and discussed origins of the construction site. So that would be supportive evidence of that hypothesis. So there's a lot of different angles we can look at this.
Sure. And would you say that mathematics are one of the languages that allow us to interpret and understand these sites, or is the language to interpret these sites?
I would say it's layers of information. It's language to understand the architecture and the design of the sites, but they can be multiple. They can be multi-purposed. So once the geometry is based on actual proportional scales and ratios of objects, and it's set up in a very beautiful and harmonistic way, so that what we find with sound and wave energies is actually just a natural consequence of the way the geometry and the unit measurement system is designed. So it's not necessary, it doesn't have to be by design. It's just using this geometric system of units creates that in the design.
Sure, sure. Let me give you a challenge. There is a cairn. There is it's like a dolmen but underground.
Okay.
Okay, imagine a dolmen that is completely covered with earth, and it's quite long. And you are in one of those structures at one of the rooms that it has, because they all seem to have this hypogeum configuration, although archaeologists don't call them hypogeums, but they have this same configuration of one corridor and several rooms parallel within the corridor. Okay, and within these rooms that has a round ceiling, a person can speak, and the sound somehow is projected from the voice of the person to the ceiling, is projected into the ground, and it emerges. I'm not sure if I'm sure you will be able to do the conversion 200 meters away, okay, on another structure of smaller size, not connected at all with this location, and the sound doesn't lose a decibel. Okay, it comes from the ground on the other structure at the same volume that is spoken in the chamber 200 meters away. Okay, and it's not heard outside, it's not heard on the other parts of the structure because the construction doesn't allow the sound to get out. If it gets out, it happens the same as the Cephalium hypogeum, that when you are in the oracle room speaking, if you were speaking like this there now, those on the door would not understand our language because the sound is all mixed up. This is all scientific, completely proven data. Okay, I'm not going into any conspiracies of ideas. This is all articles that you can go find and read and are proven by other studies that did the same and so on. So how would you explain mathematically something like the projection of sound through the ground into another chamber?
That's fascinating. I look forward to reading more about that.
I can send you the paper. I can send you the paper. No problem.
Perfect. So the way I see this is, like, you look at dolmens, you look at memoirs, you look at stone circles, all these different configurations. What I find in my modeling system is that the spacing between these is much more linked than people understand. And so there is actually, I've seen geometric measures that are exact. I'm going down to the centimeter that link Egypt to Neolithic France. And they're in the exact center of a memoir to an exact point in Egypt. So there's tremendous, even though you say that there's at distances, they are linked through a geometric measurement. And this geometric measurement would potentially be similar to like a wave front. You have a crest of a wave. So if you can put the crest of a wave at the right point of the crest of a wave through the spacing of 2 points and 2 sites, that would be an interesting hypothesis to check.
We think that the two places are linked by blocks of stone that are completely tied together between the bottom of the chamber and the other floor of the chamber 200 meters away, and the sound goes through the stone. But without work done on that, it's impossible to prove how it happens. But archaeologists, what I find bad about science is the fact that they find a lot of fantastic things that cannot be explained, and they don't pursue it. They just claim it as casual and interesting, but it's not. They don't go the further mile to see how it happens, why it was done. So that's why we're having this conversation, because we are looking to all angles in order to try and reactivate the sites, because we believe that these sites are not tombs. They are
Oh, agreed.
functional buildings that was built purposely for one or multiple functions.
Agreed.
So is that
Yeah,
what
no,
you've been finding?
yeah, that's what I'm finding. And so in the pursuit of trying to get academic publication of my work, I had a lot of people when I was talking about my discoveries saying, well, just write a book. And I did write a book. I wrote 2 books, but I didn't publish them. One book I sent to a co-writer, and she said, this isn't entertaining. It's too scientific. So, okay. So I submitted it to a university press, and they said, so I rewrote, expanded it, and wrote it and sent it as like a thesis to university press. And in conversations with the editor, he says, this is novel science, novel mathematics. So we won't publish it because it needs to be vetted in the peer-reviewed literature, and then we'll publish it. Right? So I went to and put one peer-reviewed paper out saying, well, here's the mathematics of the sites. This is how it links to real objects and the scales and proportion of objects. And here's a few sites and examples of how that is done. One of the editor went out to reviewers. One of the editor, this is kind of highlighting the challenge of dogma, said this math hasn't been invented yet, so you can't publish it.
So how is it is there on the paper and hasn't been invented yet?
Exactly. And isn't that the purpose of peer-reviewed literature, to introduce new concepts as hypotheses for other scientists to test?
Sure.
But this reviewer was saying that new hypotheses should not be entered into literature.
So how do we evolve science?
Exactly. So I just go to another editor. So I've probably put in, I'd probably say over 20 submissions, and I've had 2 successes with it. And I'll tie into how I got those successes. So I reached out to one editor, and they said the rejection I just talked about, which also includes Stonehenge measurements. I went to another journal and I said, I have evidence, and they said they want more evidence. How do you want me to do this? Do you want me to break it apart as many journals, many papers, or a single paper? And they said, we'd rather you have it as a single paper. So I put together an unprecedented 140-page peer-reviewed manuscript of all the sites I've studied, and not even all the data, just a lot of it. And I submitted it to the editor, and the editor said back to me, there's no published evidence in the literature, the peer-reviewed literature, that shows math was used in the Neolithic period. So we can't accept this. And I was thinking to myself, okay, I just gave you 140 pages of evidence. Can't there be a first evidence? There needs to be a first.
But sorry to interrupt you, because that was exactly my question a few moments ago. Because if you maybe if you suggested a new type of language to explain how these things were done, because I understand their view. The Neolithics are not supposed to be doing equations. We don't find equations on the caves paintings, so they will dismiss it. But what you are presenting to me is a language that allows us. It's not their language used, because probably they had other symbols, other ways of calculating. Although it's all mathematics in the end. But what I'm saying is that you created a language that explains mathematically. There's something that we can understand and decode to explain the ancient world. Am I closer to the truth, or?
Yes, very close. The formulas, though, are not novel. They're actually been with us since the Sumerians restarted recording time and writing. These formulas are 360 degrees in a circle, divided by 60 arc minutes and 60 arc seconds. These are formulas of 24 hours in a day with 60 minutes and 60 seconds. These are formulas of 12 months into 30 units. These are existing formulas. It's not new math. It's just the application of geometry to the sites using what we already know. So what I discovered after all the failed attempts, one editor who I was working with, not like an editor I hired to help me work on the papers, she goes, since you're getting rejected on all these references to pyramids and Neolithic structures and giving those as examples in the application, she goes, take all that out. Just introduce the modeling. So I did. I took out all the modeling, took out all references of ancient sites, and just introduced it as a proposed new method for modeling matter, space, and time, and it got published.
Jesus.
So it has to be interpreted as my invention, even though it's not. It's just a interpretation of the mathematics of the ancient sites.
Sure, sure. And do you know a site called Chaco Canyon?
No, it doesn't ring a bell, sorry.
Okay, so in Chaco Canyon, you find an extremely advanced solar calendar that it's now partly destroyed, but we can actually still see how it was done and how did it work. So there's no fallacy here in the science because it's quite clear. And you'll find several petroglyphs that are those circles that you are describing. That's why it came to my mind. Those circles of dividing the circle in multiple lines. So perhaps it could be 10,000 years old and Sumerians just adopted it because...
Agreed, yeah. Once you understand the geometry, you can adopt it quite easily, and you don't really understand how it is and why it is. Why do we use 360 degrees in a circle? We don't know. There's a lot of research around that, but I'm starting to explore how 360 degrees in a circle can also be looked at as 360 units of a line. And that line, through what's called an arc length, can be connected at the points, creating 360 degree unit length line and a 360 degree circle.
Sure. And could it also relate to the fact that when it was created, we have 360 days until the sun returns to the original point?
Actually, no, I think that's a Eurocentric interpretation of a calendar system. The 365 point whatever days rotations, but yes and no and now, it still applies. When you understand it as a modeling of a cycle of time, and time is a linear measurement from a start to a stop, you can divide it into 12 and 30 for 360. It doesn't matter the duration and the quantity of that. So you can, and they use this for Mars 24 time. Earth's rotation is separated into 24 units. Mars rotation is separated into 24 units. Both are used for Mars 24 time and Earth 24 time. So it doesn't have to be linked to 360 days. 12 and 30 can be used for any time measurement, be that a rotational period, be that an orbit of any planet.
Sure. But my question is, do you think it's related to the division of the circle? Because I'm just wondering, the first one to set up a stone on the summer solstice, for instance, and then he mapped with stones the positions of the sun until he finally came back and he counted 360 days. Wouldn't be automatically in his mind to divide a circle, because that's what the sun has been doing, to divide the circle into 360 degrees. I'm just speculating.
And I agree. And I don't like speculating in that sense, and it's fun to speculate, but I look at more just the pure mathematics of it. And so the reason why I don't speculate as well is because when I look at the mathematics and apply it in the sites, 360 is used. 1230 is used for a time measurement, and it can be any time measurement. And I can link a spatial measurement with a time measurement to create spatial temporal units of measure. So there's entire new applications that are very well mathematically defined that don't need that speculation.
I see your point.
Okay, so there's different ways to look at it for sure.
Yeah, I see your point. For instance, another site that you might not be aware. In Malta, there is a site that is completely shaped as an array antenna tuned to 833 hertz. And in the Lampadelo Island, if I'm not getting the name wrong, 60 kilometers away in the middle of the Mediterranean, straight in front of it, so there is no way to understand how they managed to do a complete straight line through the sea 60
Mhm.
kilometers away. Okay, and the other side there is a cocentric circle that, according to I think its name is Steve Marshall, but I send you the paper and then you'll check for yourself. He found out, he's one of the lead members of the creators of the protocol for archaeoacoustics. Okay, he's a top member of that organization and that society of people that study archaeoacoustics and the ancient world. Is on the top of the list. But he found something that even they couldn't accept, because he found that sound produced at that specific temple that has the shape of the antenna was received without loss of volume 60 kilometers away on the other structure on the island.
Mhm.
So this is what was is the proof of an ancient system of communication through great distances, because on the other point of the island, turned to Africa, there is another coexcentrical ruin, and on Africa there is another structure that's look like the shape of a array antenna. So he created the paper, he presented it, and he was not allowed to further investigate it.
Mhm.
The only thing he could prove is the fact that sound projected through water, instead of keep going longer and longer, the waves of the sound, the coolness of the sea would recompress the waves, and because of that the sound would get to the island at the same volume that was given at the source. So this is something that we don't even use today, but I think mathematically could be interesting to try and decipher it.
It would, from my standpoint, I wouldn't be studying the propagation of the wave through different mediums like water or land. What I would be looking at is the actual distance from point to point, and understanding that distance and how and what you can use SI units like meters, for example, which I think anyway. So that's another story. You can measure any geometric measurement of a line that's a scaled ratio of an object using any standardized unit system. It doesn't matter. You can use a foot, a meter, it's a cubit, whatever you want to do, because the geometry will still be consistent. So it's that geometry measure that I use. So I convert the SI units into a geometric measure, and that geometric measure, more often than not, is a scaled representation of an object.
Okay, and that model that you use is the 360 part circle.
Yes, that's for. So the interesting thing about it is that 360 is used as a spatial measurement, and there's a paper I'm working on right now how you can through the arc length and everything, how it's all related. But 360 formula is for a spatial measurement, and a temporal measurement is of 12, and you can combine a spatial measure with a line of time, and you can create a special temporal measurement as well. So you can basically use a line segment and use a time to put yourself on that. So my first paper, I introduced a one-dimensional orbital model where you can put the time of a planet's in its orbit, whatever day you want it to be, on a one-dimensional line. So that was the introduced already in the literature.
And that's, I think, a confirmation of your calculations, right?
Yeah, and
it's accurate.
Yeah, just took it from the ancient sites, and I'm just applying it to whatever I want.
Sure, I see. Okay. But because if we are to explain ancient sites and its capabilities mathematically, I think apart from those like you that understand that language, because I'm terrible with mathematics, but I think after it being translated into your system and then translated into words that most people, for instance me, would be able to understand it, I think would be super interesting.
Well, the interesting thing, everybody says that, well, not everybody, but a lot of people say, oh, I don't understand math. What's fascinating about this is that this math is more simple than anything we currently use. It's geometric math. It uses natural numbers, which is 1, 2, 3, 4, 5. It doesn't use real numbers, 1.3, whatever. It doesn't use rational numbers of pi, square root. Those are all, in my opinion, man-made interpretations. The ancient sites are using simplistic math that is based on Euclid and geometry, and it's not the modern interpretation of it. The introduction of calculus, like by Leibniz and Newton, in my interpretation of that is, so my speculation is that they needed to invent calculus because we had an interpretation in Europe of a continuous spectrum of infinitesimals. That was not the case in the ancient literature. It's not the case in the ancient mathematics I'm decoding. All the systems I've decoded, and if you look at the ancient mathematics of the Chinese Mohists, it's discrete mathematics. It's points, lines, and that's it. And so what I'm learning from the decoding the sites is that those lines and points and planes are used. That's the math. It's a geometry. So the language is the geometry. What we don't know how to do, and what I'm trying to introduce, is how we can basically convert the line between a menoir and a circle and say the distance between here and here is actually a scale distance between the sun and a planet. And I can show that with absolute precision. And I can not only say this is the distance between a star and a planet, I can say this planet is actually in the alphelium position. And because there's another marker over here that's in the perihelium position, and those measurements align.
Okay.
So knowing math in the ancient math, you don't need to know the current interpretation and applications of mathematics. There's no infinitesimals, there's no calculus, there's no rational numbers or irrational numbers, sorry.
And do you think that, for instance, we spoke before starting recording about Washington, for instance, and we can find that in several cities and how they are organized and built. But do you think that is the language used by the ritualistic, let's call it sacred geometry implementation to construct a site to create a certain effect? Is it just symbolic, or do you actually believe there is something behind it, some hidden power or some energy or some practical effect to be obtained from that type of application of that mathematics into creating a site?
I think each is equally interesting to pursue. From what I'm taking from a like empirical standpoint and the mathematics standpoint, and I like to go down the other roles, but I'll just focus on that right now.
Sure.
It's a way to maintain the knowledge. Okay. So once you learn how to decode it, you start to see the connections of where everything is connected. So I see, for example, the Vatican is made with the geometric measurements. Neoclassical architecture, such as the Washington monuments, is made with that. And it allows you to basically understand that they understood it, and it's still being passed on and used even modern structures today. There's statues and monuments built in these units. The Statue of Liberty is built on 19 units of a scale of Earth. The recent tower in New York City, that's on 111 West, I believe, I forget the 57th Street or Ave. It's built on the unit of the moon, which is usually looking at feet and inches, they say what it is, and I just compare that to the unit measure of the moon, and it's 325 units. So everything's natural numbers, 325, everything is a unit of the geometry, so the line from the bottom to the top, and everything represents an object, the moon, the earth, the sun. And once you can understand how to decode what we know, the distance to the earth to the moon, you can start to use that system model. So basically, if we go into computer theory, there's some called discrete event simulations. And so you can have object-oriented discrete event simulations. And if I apply that theory to the sites, it helps considerably into mapping it all out. And it's very much aligned to it. So once you learn how to use a canonical reference, which is taking something you know to compare it to something you don't know, you can interpret the sites for what you know in the scale that it's built. And you can decode information we don't know and we could never know. So I've been able to decode information of other star systems, the distance to the star system, the number of planets orbiting the star system, and in one case, the moons orbiting one of the planets, either two planets, a binary system with two moons, or one planet with three moons. Haven't figured that detail out yet. I can tell you the orbital distances. I can tell you the orbital velocities. I can tell you the dimensions of these planets and moons, even their axial tilts and their orbital angles relative to their planet.
And all you need to do that calculation is?
A ruler, a protractor, and a compass. And so once you understand the formula and how to convert it, I could, if I sat down with somebody who knew how to do computer AI programming, we could set up an AI algorithm to decode all the sites pretty quickly. It's a basic mathematics. And all you do is a scan of an aerial view, and you can also do a scan looking sideways and looking up, so the height of things. It's all zero-dimensional points, one-dimensional lines, and two-dimensional planes. And
it's very interesting.
So one of the sites I decoded, for example, I just Googled. I had the data information of the data decoded from the sites, the orbital distances, had the distance the distance calculated to the star system. And I just went to Google and I said, okay, what star system is this many light years from Earth that has 4 planets? And then it comes back to me as a perfect match. The distances I calculated from the Neolithic sites are within the error bars of peer-reviewed publications of that star system. And all 4 planets.
So you don't know what you're going to find. You just
don't know what
find
you're
it.
going to find.
Okay, I see. Well,
so I had the math, I had the distances, I had everything mapped out. I just didn't know what it was. So I Googled it and found another star system that matched it.
Sure. Well, I will try to help you with AI, because one of our members is an IT himself, but he is connected to some AI investigation groups. So I'll pass the word, and I will let you know what they say. So if you say it's a simple thing, maybe we can make it happen quickly and see what answers we have. And from your perspective, does this give you some sort of answer beyond the mathematical result? How do you see it?
I see it more as questions that lead to hypotheses that are difficult to dismiss. So I can gain information from, and it's not just one site. I'm not just saying that this star system I've decoded and the planets and everything. It's not on one site. I see it everywhere. I can decode it from multiple different sites, the same information. Applied to different circles, to different pyramids, etc. Using the mathematics of the units. And so what it shows is that because we have known information of the star system, but I'm giving more additional information, it opens up the questions of, well, can we point the telescopes that look at exoplanets at this star system and address if this planet, this orbital mass, which is called an exoplanet, is actually 4 different bodies. That would give supporting evidence that this information is valid and decoded properly. It is also very supportive that it fits within the error bars of the current publications, but I want to be able to predict something and then have that prediction check out. That's ultimately what you want to do. Then if that is supported, even if it just adds support to that hypothesis. But right now, what I look at is, even with the support I do have with this hypothesis, is this is information that you can't observe from Earth. I can't observe the axial tilt of a planet in another star system.
That's what I was about to ask you. How were they made to tell us like a map of the cosmos without knowing the cosmos in the first place?
Exactly.
This is what I'm going to ask you.
Right. So there's different hypotheses. You could say, well, did we just intuitively know that? Was there some way for us to empirically measure that from Earth in a way we can't do now? That's a hypothesis. I'd say it's a low likely hypothesis. Another one is, was there some sort of communication where we received that information? And again, not fitting any technology we have now, because radio signals wouldn't work or take a very long time, and we'd have no radio receiver for it. But as you said, with the sound transmission, maybe there is some technology that we haven't thought of. So that's another way where we communicated. Or were there another hypothesis, did people with that information or entities with that information come to visit us and tell us that information? Or another hypothesis, did somebody come with that information and build them with support of people here or without support of people here?
Sure. Well, that would fit very well with my own cosmology, because I think this is a bit of a detour, but I believe humans are non-natural because we don't belong to nature and we don't belong anywhere else. We are just a lost species that found itself on this planet. So that would imply a mixture between creationism and evolution. So as if some entity decided to cross a bonobo, I'm not sure if you know the race, to cross a bonobo with their own genes and create half gods that would fit with the mythology and ancient tales and so on. But my point is, according to this line of thought, we have a type of creature that is called, to me, the shepherds. And the shepherds are given galaxies to shepherd and to just oversee life, just to make sure that life goes without some sort of catastrophe. If there is a catastrophe, they make sure they send another, what I call LSP, or a life-creating probe, like Oumuamua, if you remember Oumuamua. That would be interesting for you to check the measurements. So Oumuamua was an object that entered our solar system. It was completely impossible to predict his movements because they were erratic. They changed course, they speed up, they slow down. So it was an object that entered and exit our solar system without us understanding what it was. We even have scientists saying my only explanation is that it's either intelligent craft or some sort of probe. That's the only possible explanation. But I believe that is one life-creating probe, something that impacts a planet and changes life. For instance, when there was the destruction of the dinosaurs, if you want to create humanity, you can't have those big animals running around. If you want to live on that planet, you can't have those big animals running down. So you create an event that will reformulate the planet. In this case, would be a terraforming of the planet Earth, that without the moon would not be possible to have life. My previous guest on this program was Brian Corey Dobbs. That I suggest you see his film that is called Red Planet Blue. Okay, so he talked with scientists, NASA people, just scientific people, and some investigators about Mars and the fact that Mars has structures and configurations that are mathematical, are geometrical, as for instance the plane of Sidonia. I'm not sure if you know the DNM pyramid and so on. So it's all geometric. It's all about solids, the structures that we find there. So we presume they are not natural. This all came from Richard Hoagland in the 80s. But my point is, Mars was probably the first system to have life, because the Earth without the moon couldn't support high evolved forms of life because of terrible weather, terrible winds, fast rotation. It was very difficult to do so. So the moon, the entrance of the moon in this scenery created the possibility of the Earth to actually have life, which is very convenient. And as I used to say, coincidence takes planning. So then again, just to justify what you told, is I believe that these creatures that, in my case, rebelling, decided to create humans as Satan decided to create other beings to his image, or in the case of J.R.R. Tolkien, how
the master of Sauron, that I can't remember the name right now, also decided to create beings because he also wanted to be as the created, and why can't I be free, and so on. So I think humans were created in that same philosophy of, and these beings that I call both the slavers and the teachers, being the slavers, the ones that construct sites like Angkor Wat, or sites where you see massive grounds of architecture for sustaining lots of people. And then you find sites like in Peru that are very small, that the record shows us that there was no leader. They were all of the same class. They all live in equal houses. They all have the same responsibilities. There's no one above no one. And I call those the teachers' sites, because that's where we see a different kind of existence that's not include hard labor and so on. So these people would know these systems because they were guardians of galaxies. So they would know exactly what's going on. So it would be possible for them to determine the location of these ancient sites because of that knowledge. So I gave all this speech just to get to this point. So I think it's possible, yes, that the location was known. But if it isn't, and this was going to be my question before you started your last speech, is do you think that mathematically it's such an universal way of explaining the cosmos that whatever you do, when you do it right, you get results that lead you to other things, because as above, so below? Do you think that could be also be an answer?
Well, do you know what's interesting? So above and so below. It's also, the mathematics is based on reflection and rotation. So it's dihedral mathematics. And so reflection is above and below, or side by side, however you want to look at it. It shows its reflection. So the geometry includes that within the structure or the classes of the units. So every class of unit has a different dihedral property to it. That allows me to create a class for a particular application, a class for time, a class for spatial, a class for orbit, a class for rotation. So I know how to divide the geometry based on its class to give me the right information. So it's universal. We see this symmetry throughout nature. It's everywhere that we look. The other thing is that once a society understands, like the way I look at it is, we couldn't have come to this conclusion, or my work wouldn't have been possible even 100 years ago, even 50 years ago, because we didn't have the technology to be able to decipher it. One of the leading things I used was Google Earth to create the measurements. When did that come available to us? Right? So, and I needed to be able to research sites from around the world, literature from around the world. When was the internet and Google set up for allow one person to do that? This is all just recent advancements that allow us to do this. The other universal thing that's needed in this sense is you need to have a dimensional standardized time system, or a unit system that includes a uniform time system, like seconds. You need to have a uniform measurement system, like meters, that's linked to dimensional constants. If you have if it changes like it used to, 24 hours a day was always linked and always changing, that's very important, and we need that, and that's what the ancients did. But we also need what replaced it in our modern time, is the uniform time of a second. So when you combine the ancient system with our modern system, that's when the beauty of it unfolds, because you can now, through geometry, find out every orbit is different period of time. It has different measurements of distance. And that is consistent through a rotation of a planet, for example. So when I build a discrete event model, that is referencing what's happening at that moment in time. All the geometry measurements are of that moment. So if I were to go ahead in 100,000 years, I could find what I'm referred to in my publication as temporal anchoring. So the geometry allows me to temporally anchor that site, that architecture, that design to that moment in time.
I see.
And so that universality of using geometry and the alignments and signals in a real world system, as it's called, and building that into a modeled system and linking them so that it aligns to sunrise and summer solstice. So the person knows, oh, that's the signal for summer solstice. That's here. Oh, it's the new moon event. Okay. And then they just run the calculations. They can anchor when that actually occurred, when this was built or started and designed anyways. So you really need to have the connection of the universality of a civilization that has the technology that we do today, not 50 years ago, but today, with the approach of the ancients. And once you combine both of them, then you can understand and decode all this data set.
So, for instance, in Long West Kennet, also in Scotland, another cairn, the actual leader of the archaeoacoustics protocol, that is Bartoli, placed a 14-year-old child within a chamber, and outside the drum was beaten about 8 beats per minute on the forecourt of the site. So the child started to, it's complete darkness, just keep this in mind for the child. This started to see the stones glowing, first of all. After that, an opening opened on the wall, the stone walls, which we know there's nothing on the other side but the field. So an opening was there was an opening. Let's say grow an opening on the wall. The child could see that there was another room beyond the one that he was, but he got frightened and he closed his eyes. The only thing we have further than this is the fact that for 2 times he mentioned that he felt a presence in the room with him that decided not to interact with him and left him and went away. Okay. So my point is this. If you are a top researcher and you have this description from your own test, you go and try to see if it is in the mind of the child, and if so, could it be experienced like an OBE type of experience? So it's real for the person, but it's all on his mind. Was it physical? So there's no cameras inside that could show us this, and it was not repeated. So was it physical? Did actually an opening open on that door, on that stone wall? So he decided to go himself into that place, but he violated completely the rules of the site because he took headphones. He didn't put anyone playing an instrument on the forecourt. He took headphones and used the binaural sound to create some sort of state within that room. What happened is he's the one that measured the actual place. He knows exactly what 1 meter is, what 2 meter is. He's one top expert. He's called to measure sites, and he can do it very precisely with his eyes. He's known for it. When people go and check, his eyes were actually pretty close to the mark. So his description is the site throw him 4 meters into the air in a chamber that has only 2 meters and then a big slab of stone. He was thrown 4 meters into the air. That he confessed he was quite alarmed. And then he was thrown into the floor of the room. And after that, it happened 2 more times that he said he was getting used to it, and then things relaxed. To me, what happened is the site actually introduced the wrong key, and he was rejected by the site. That's my reading, okay? That's my reading. But what I want to ask you is this. Could it be that, like in an holographic world, the smallest parts has the imprint of the whole? You can find the whole of an holographic image in 1 pixel. It has to be there for it to work. Or so I'm told.
No, that's interesting. It actually ties into the physicist Leibniz, who says at one point called the monad. It's more of a philosophical theory, but that monad is a point of no dimensional properties, but yet it controls all the information.
Okay, that's exactly what I'm trying to get. Thank you for the clarification. So could this energetic lines, these ley lines, this telluric energies that we see have specific grids upon the Earth, be in itself a representation of the whole galaxy or the whole cosmos, and that's why you find those relations exact, because it's the information encoded in the energy, and then we chose the sites through that focal point of energy.
I think I can see it all interconnected. Everything I look at is interconnected to something else. And so I haven't explored the mathematics of sound and sound waves yet through the mathematics. I think that's a phenomenal area to explore. Also, when you study the dimensional systems and the works by Maxwell, who's the father of like EM waves, he had 2-unit system, or a 2-system process that include motion. And that created basically, if you take a spiral, if you know, an Archimedean spiral, if it's a circle unless you put time into it. So if you put a time displacement, it creates that movement. So it opens up a whole new area to look at sound waves in respect to dimensional measurements, because Earth, in a sense, if they are connected, Earth would have its own specific resonance. It'd have its own specific dimensional quantities that need to be represented in the mathematics of the sites. So that would tie into the spatial measurements I talked to you. And so if you wanted that resonance or that sound properties on Earth, you would build it in that geometric scale. And so that would make sense. And for me, it's called countable infinity. So I can create a spatial scale of the universe at a countable infinity. So I could basically take the entire known universe and all measurable like normal matter dimensions and put it on the size of a quarter. I could put it on the size of a pin of a needle. I could put it on a dimensional size that's smaller than our physical universe in Planck's limits. Because it goes to infinity, you can make it as small as you want. So you can take the information of any universe, the spatial information of any universe in any scale. Let's say there's 2 scales of 2 universes, one we're in a smaller scale universe. The time's faster and it's a smaller unit. You could take the dimensions of our universe and transfer that information to that universe. Of course, that's just hypothetical in theory, but looking at the mathematics and looking at infinity of the scaling system, the mathematics would work from showing the geometry at any scale.
Sure. So would you go that as far as to say that, for instance, we have the suspicion that we see lots of false doors in very ancient sites, and we have seen so many fantastic and absurd things for scientists actually happening in these tests that they are doing, that we have to at least put the hypothesis that false doors are but connections to other points. I'm not saying they are other points in time or space, but they could be the connection to other points. This was reminded me by what you're saying, that when you scale it, you create connections, and you spoke about resonance. And if you have a signature of a place and you connect it with a signature of the other place, you can create a line linking the 2 signatures, and then for space and time does not exist between them. So at least theoretically. So would you say that you could explain that mathematically according to your descriptions?
In ways. So there's parts of it that could. So for example, right now there's a huge issue. There's lots of top leading physicists who say physics right now, the way they model time doesn't work. And so in my papers that I've published, I'm changing the way we model time. I'm not using infinitesimals, I'm using scales. So the scale of time that we see is our dimensional reality. And so when we say that when you go to quantum superposition, where you have a 0 moment in time, there's no quantity of time that can be measured, but yet you have 2 potential locations for that information. This breaks makes people flip, because our model math doesn't work. They consider the time in between as infinitesimal or infinite. So they don't understand how that can work. So my system, and they don't also mathematically say that time can equal 0. If you make time equal 0, the vast majority of physics equations are blown up. They don't know how to work with that because you can't divide by 0. And so what my system allows us to do is I don't use time derivatives, which means velocity and acceleration, which is what physics is based upon right now. I use time integrals, which is a length given over a quantity of time. Now, what this does, to your point, is if I have a length over a quantity of time, I can have the distance between 2 points defined by a quantity of time in any scale. So in our scale of time, you'd have to, how long would it take you to get this point to that point? But if you were to be in a smaller scale of time, you could go from this point to this point in between our time. So you could have a 0 point in our dimensional time, but still have time in a smaller scale.
I see.
So you could move in our reality, it would seem like it just happened. You just show up.
Sure.
But in another smaller scale of time, there was movement.
The movement, yes. But let me correct myself, because what I meant is you create the signature where you are. You create the signature of the other place you want to go on that frame door through everything I told you, through the energy of the site, through the mineralogy, through the hydrology, through the sound frequency vibrating the crystal. Because we find in these places that I've been describing you, they have sarsen stones. I'm not sure if you know what the sarsen stone is. The sarsen stone is quite a misleading name, because what it is actually, geology speaking, is 99.529 pure crystal. That's a sarsen stone. Okay. So it's a gigantic, it's a building created with gigantic blocks of pure crystal. There's no pure crystal that we can make than these sarsen stones. They are 99 point, the less pure are 99.3. So they go all the way up to 99.8% pure crystals with a very tiny amount of impurities in them. So we are talking about very large types of material that can be made to vibrate and to create energy, to absorb knowledge. We have been finding many uses for crystal in the last decades. So what I was meant to say is, you create the signature where you are, you create the signature of where you want to be, and if you get the exact signature of that place, it ceases to be a distance and a time between the two. So the door will become the other side. So sorry, go ahead.
No, that's very interesting. And I would love to pursue that more. So with my mathematics, I can create coordinates, mathematical coordinates of relations. So in any point of 0 time, I can create a coordinate for that point. So it's based on relationalism. And relationalism right now in the literature, up until last year, has been a theoretical. I'm bringing in the physical theory for relationalism, the mathematic formalization of relationalism using the ancient geometry. So I identify a point, an identified point, like you're talking about, through distance relations specific to a single moment in time. So if I can set coordinates for, just like if you have a quantum superposition, it can be in 2 places at the same moment. Each place has a coordinate. And that coordinate is what I call a spatial temporal triangulation. So the spatial part is its relation to other bodies, and its temporal part is what moment in time, the 0 point in time. So every point has a spatial temporal triangulation. So if you, to your point, go stand on a point and set the coordinates of where you want to be, then you could have another point with those same coordinates received, and then you just need to link the 0 point in time, and they would connect the sites.
So basically, we just decoded Stargates.
There you go. That's what I was missing. I was missing the sound component. I need sound.
Well, I might be biased, but after near 36, 37 years of diving into the ancient world, sound was the thing to connect all the points that I've been studying. So it's not an eureka moment, but it's when you realize that you needed a link to put all the other stuff that you know to work, because it's like having the car but you don't have the key or the right code to start it.
Exactly.
So
And in my journey, my journey thus far is proving to me that it's meant to be a team effort. Like I've talked to mathematicians and I said, I need this formalized in set theory. You're a set theory expert. Let's just sit down and do it. They said, no, you have to learn that. I'm like, why do I have to learn that when you already know it? Like, why can't we just do it together? So I think there's experts on every team, and every team expert has their role to the goal of the team. I think once we understand that we're all pieces to a puzzle, we can unlock the puzzle.
absolutely. I was just talking to someone on X, saying that we cannot, for instance, from the human point of view, and not the structural, but from the human point of view, if you want to understand the human origin and beginnings, you have to get some data from creationists, and you have to get some data from evolutionists, because without both of them, you cannot go to what is in the middle with points of information from each one, because they are both right and they are both wrong. The problem is the absolutism that exists in science, and they don't mingle with one another, because that would be opening a door, a floodgate of ideas that then they wouldn't understanding where they were or what to say, because there would be so many explanations new. Like you, it's too novel. It hasn't been invented. It's there how it hasn't been invented. So I invented it. Let me add to the paper that I invented this because it hasn't been invented yet. So we need we need all areas of knowledge. Go ahead.
Yeah, no, sorry to interrupt. I always interrupt when I get passionate, and I'm enjoying the
Go
conversation.
ahead. That's why you are here.
No, I agree. Because, for example, I'm not inventing it. I'm just describing it for the first time. And I think a lot of, like, Pythagorean's triangle. How many times have we seen that before Pythagoras? Things exist long before. And yeah, it's just phenomenal. That when you look at the academic structure, it's publish or perish. So you have to publish, and I can't publish what I'm doing. I'm having difficulty. So if an academic professor decided to do what I'm trying to do when it was funded by the university, their chair would say to them, drop it. You haven't got a publication. You've been trying. This is too novel. Editors aren't going to pick it up. Do something that we know is going to get you published so you can get grants. I think once this enters into the published domain and the peer review, and they have ability to reference it, that is key. And in the peer review literature, you can't reference something that's not peer reviewed. It's an infrastructure set up that is not innovative. It's against innovation. It supports the status quo, but it's what we live in the moment.
Sure.
So, for example, I took there's a calendar called the Goddess Calendar, and this was looked at from an interpretation of Neolithic China. And they looked at 13 lunations as 1 year. And then what I did was I found out about this calendar because I decoded in one of my sites, a Neolithic site at 7,000 years old. I said, okay, this one line segment, this one orbit, and it aligns to orbits of Earth, it aligns all that kind of stuff. It's a phenomenal line and has 4 different calendars in it. Anyways, one of the calendars decoded 13 lunations, 13 new moon lunations, and linked to 384 days with another stone in the proper dimensional measurement to indicate there's another day there. So it's like 384 plus 1 for 385, right? So I just Googled what calendar, and I'm like, those aren't calendars, there's 365 days, or like, what's this 384 day? Because that's what the math showed. I Googled 384 day and came up with the Goddess Calendar, which links to the Neolithic China. And then I have a preprint that's out that I'm looking right now, building collaborators for, to test this calendar hypothesis against the Mesoamerican calendar as well. And I've also already published the testing of this 13 lunation calendar against the ancient Egyptian pre-Roman or pre-Greek influence on their calendar system. And it gives a new hypothesis that aligns with data like Paprius that is not able to be currently interpreted under the current understanding of calendar systems. So that created a new hypothesis for ancient Egypt's lunar calendar system, and we're exploring that in Mesoamerica right now.
That's amazing. Looking forward to read it once it came out. Looks very interesting. I've been expecting to speak with someone high in mathematics in order to make this question. Is there time without movement?
It depends on what model you're looking at.
So in the model that we experience.
Well, again, that depends on your perception. So let me answer it in those contexts. So in relativity, no, absolutely not. In the way Einstein defined the relativity, no, you need an observer and you need space in order to quantify time, because time is measured as a displacement of light. So you can't have time without displacement. That's a model. That's a mathematic model. That's it.
So that is the simple explanation on why the universe must be expanding or contracting, because without that movement would be no such thing as time.
In the way we model time, that's how people say if there wasn't matter, there'd be no time. But yet they contradict themselves, because they say they take in their equations time to infinity. Well, I'm sorry, but the universe wasn't here to infinity before the Big Bang. It was like time, they're modeling in contradiction. So they say time goes to infinity, but they're using the speed of light, and a photon didn't get created before the Big Bang, theoretically. So there was no time before the Big Bang, and yet they're saying infinitesimal time goes in both directions. So they're contradicting themselves.
But doesn't it fail in the notion that light is the fastest thing there is when it isn't?
Light is the fastest thing with dimensional properties. So if you don't have a dimensional property associated with it, energy, pure energy equivalent state. But
there was a study using sound where sound was 2 to 3 times faster than the speed of light.
Well, the challenge with sound is that you need something to propagate it. So
Sure.
It needs to go through something. What my papers have shown is a different way to look at time entirely. I don't model time through space. So Aristotle said time needs to go through motion. To skip ahead to Einstein, you need to have space displacement, have time. For me, time passes through a point, not space. So there are paradoxes in theory of relativity that if you pass time without space, then it's a paradox, doesn't work. And there can be no flow of time. That creates paradoxes in the theory of relativity, because you have space. How do you flow time? It's based on an observer perspective, and it's using space. It's a model. And so in my model, again, just a model, but in my model, I don't get those paradoxes, and I don't need space, and I don't need motion. I need a signal received at the point. So I don't need to look out to see time. Time comes to me in the sense of I saw something, and then I saw it again. The duration between the signal is time. So I don't need space. I just need 2 signals received at this point.
Sure.
And so that is the measure of time that's independent of space. And so I can create a time measure for a point independent of space, but then I can create a measurement in 0 time at one of those signals to another object. And so that creates an independent measurement of space that's relative. And so that's in my first paper, how I separate time and space for modeling matter, space and time.
I see. Well, it's because to me, time is completely artificial. It's a man creation. It doesn't exist beyond the point of needing to see when and where. So beyond that, I don't see any marker of time in nature. There is no need to measure time. Nature reacts instantly to whenever it is, be it summer or winter, or being in this side of the sun, on that side of the sun. It doesn't matter. It's just a perpetual present. That's
Absolutely. So, and that's what in my theory, in my physics model, that's exactly what you just said. So right now in the theory of relativity, the challenge is that the past, present, and future exist in a block universe. It's already there. Your baby exists, you exist right now, and your grandfather, your older self exists. It's all there. That's needed. It's a output, if you will, of the theory of relativity. In my theory, I don't. I just have a progressing present. So I have a present. That's it. So the past is a memory that you hold in the present, and the future is a prediction based on the past occurrences.
Exactly.
And that's the mathematic model. So the paradox and the challenge of Einstein's theory of relativity is taken away in the theory of relationalism.
I see. Well, I used to say that the present is when we have the memory of the past in order to gain wisdom to decide the future. So, but it's always a present, because you cannot be in the past and you cannot be in the future. So it's a perpetuation of right here and right now. So that's why on that movie Spaceballs, when he said now, no, not now, then now, no, not now, then. And so because it's keeping moving the moment, it's never stopped, because it's a constant present. So and do you think your mathematics could explain why time is relative, at least physically and conscious related?
So I guess another way to say physically and conscious is related is time is relative based to the observer. So that's entirely Einstein's system of thinking. That's the way the model works. It's the origin of Minkowski's light cone. You look into space and time to see an event. So that's what we're observing. And in the system I'm working on, it's more of it's not an observer point of view, it's an omniscient point of view. So you're looking down at all the observers. And so I don't have an observer's stamp of time. I have a stamp of the time of the universe.
Yeah,
so I can
maybe I made the wrong question. What I mean is, we can experience time in different portions for the same minute, because we can have a minute that lasts for an hour, and we can have an hour that almost looked like it went by in 1 minute. So that's why I ask physically and conscious related.
Okay.
So
this, sorry, I think I understand then. Physically, I think we're tied into what we have. And so it's our scale of time in a physical dimension. And that's why we can standardize it. But in my paper coming out, a manuscript I'm writing, I'm scaling time. So you can have different scales of time, which means that in a smaller scale of time, I can have more experiences within that dimensional minute that we live in now. So that can explain perhaps why you go to bed and you have a dream and you have a long experience. And then you wake up and you realize that was only 5 minutes, where it felt like you've just dreamt for an hour.
Good. A DMT experience, for instance. I'm not sure if you're familiar with the term DMT. So DMT is a natural substance that whose effect is about from 5 to 8 minutes. Okay. The thing is, there's even people that have an experience that lasts for 30 seconds or 1 minute, but they are hours and hours and hours inside that frame of time, and you can't remove them that they just been 30 seconds. They just don't believe you, because it's impossible to put all of that experience in 30 seconds. So do you think that when I ask you if time is relative, is can we as humans be here and not be here, in the sense of time can be made elastic by our own output, in energy output or process of consciousness at that moment? And can that be explained through mathematics?
So let's take the hypothesis you can. And then let's take that assumption that you can. That would fit into my mathematics. So there's the dimensional time, which we all live in, the physical. And then you would have to have an ability, I guess, to tie into a state or an energy flow that has a smaller dimensional scale of time. And if you could do that, then that would be possible. So because you would have more experiences within you'd have more experience points within a smaller scale of time. And when you convert that to our scale, it'd be a shorter period of time.
I see. So, and through your calculations, when you said you could pinpoint a place and time, no matter which time you wish it to be, and what a place you wish it to be. So, would you say that it is as easy to go? Because in my assumption, it's quite easy to go into the past because it already happened. It's quite hard to go to the future because there's too many ramifications, too many possibilities that are being created at the same time. So it's exponentially almost infinite of possibilities, because it's not just you, it's everything within your bubble of existence, in your sandbox of reality. So would you think mathematically you could pinpoint a place in time and actually resolve its signature, its frequency? It's a way to pinpoint it exactly into a mathematical image of the cosmos, if I make myself clear with this, and say it was there at that precise moment, and this is its signature.
That's interesting you say that. I never considered that beyond just a geometric measure of 1D length and a time temporal point. And so for me, those time temporal points are in our dimensional reality. They're not in like an energy state, if you will, or a frequency beyond our dimensional state. From a mathematics and a distance, yes, you can in the memoried state, as long as you have the right coordinates mathematically. I would be interested to explore the possibility if that every single moment has also a frequency, to your point, a frequency. So it's not just time and space coordinate, there's a frequency coordinate that is also relative to everything around you. So that's another layer that could be built upon the geometry and the physical dimension.
Because the mathematics that I know contradict everything I said before, because mathematically it's quite simple to go to the future. You have to travel very fast on one direction and return very fast in the same direction to the point of origin, and you'll find out that for you it was a period of time, but for those that stayed put, a long time has passed. So it's, in a way, you just traveled into the future, because that's what happened to other people, but not to you, which is curious and quite funny in itself. But because the other ones travel in the future and experienced it, while you stayed in the present and just came in the end of the other guy's journey, because they lived all those years that you were away traveling, when you were just a few minutes going in one direction and coming back.
Yeah, but that is by the theory of relativity.
Exactly.
And so my theory doesn't use any of the things that theory of relativity does. As the so basic is that I don't use an inertial frame of reference, and that's the basis of that, which you just explained. So for me, an inertial frame of reference only exists if there's a velocity or an acceleration. And then that's an inertial frame of reference, but they're both needing acceleration or velocity. And for me, I have neither, because I have zero time.
I see, exactly. And that's what interests me, because it goes to my idea that you can travel from one point to another if you pinpoint all those, how do you call each letter in an equation?
Yeah, you can call it coordinates, I guess.
Coordinates. So you have the coordinate of the place, of the time, of the frequency. If you have all of that represented in one equation, you can create, let's call it, it's not what I think it is, but let's call it a wormhole, a small wormhole that connects the two places, because there is no actual physical distance between them as soon as you introduce the same frequency, because you become the frequency of that specific point in place, in space and time.
Yeah, it'd be basically, in modern terms, it'd be putting a coordinate to quantum superposition.
Exactly.
Because the quantum superposition is two locations in zero time. So you're putting coordinate to both of those points.
Sure. But it has been done, right? I've seen articles saying that they managed to put I'm not sure if it was a proton or a neutron, whatever. They could teleported it to another place, and they
Yeah.
were seeing it at both places at the same time. It was existing in both places at the same time.
Yeah, I'm starting to explore teleportation, quantum teleportation. They still use the mathematics of time and as reaching infinity, which I don't. I have zero time. And any mathematician or physicist will tell you you can't have zero time because, in my opinion, they're textbook scientists. And textbook scientist to me is somebody who says, well, nobody said there's no textbook that says it can. Every textbook says it can. So they're textbook scientists. Whereas I build my time on a dimensional constant. So I don't build my time based on abstract mathematics. So for me, zero time is a quantum superposition. It's zero time for our dimensional scale in reality. And our discrete interval of time for our scale of time is Planck's limit. So how can we have an infinite time when our dimensional reality has shown that doesn't exist?
Sure. I see your point.
So I use a measurement of time based on constants. So if there's a constant other than light that has a different scale, a smaller scale, you can base a smaller scale of time on a smaller constant. And is that somehow, I love my speculative mind going, does dark matter have a smaller scale? Is there a fundamental constant for dark matter as there is for light? And if that is in a smaller scale of light, the Planck constants, if you will, for that are smaller, then that opens a whole new area to explore.
Sure. And what do you mean by? Do you have a proper your own definition for dark matter, or are you using the common known?
I'm using the common known and the common known understanding of dark matter. So there's a lot of speculation about it. There's a lot of theories. There's a lot of people who stick to their theory, and that's all great. I'm looking at it from my lens of my mathematic model. So what I'm saying might not agree with what other people are saying about dark matter, obviously, because everybody has their own theories. But in essence, I look forward to exploring that area for sure.
Because in my perspective, reading all sides of the discussion about dark matter, they exist, they don't exist, and so on, I think the problem is actually the term, because they are all speaking of the same thing. It's just the term that confuses them, because it was a bad choice to call it dark matter. Even the creator of the name regretted because it was a bad name, and now, because all of these times that we spend millions trying to find dark matter, and all of them came blank because we just can't find it. We just know it's there because of the mass evaluation of the universe, and there's a lot of it missing. And I think the best explanation for that would be from Ian Lungold. I'm not sure if you know the name, but he managed to do something. He tried to do the same that you are trying to do with his equation. So he is unified field theory. That's his area, and he managed to make the academic community accept his values because they were irrefutable. Like your mathematics was sound, they just don't like the relations you're making with it. So he passed through the same process. But he was left to create his own institute, and the fact that his notion of the 99.9% of vacuum not being vacuum at all, but being filled with measurable mass within that 99.9 mass of the universe, that he has a proper name for it. The fact that he managed to use that to create some sort of energy or so on, he got the funding. What we have is less Ian Lungold, because he used to do a lot of presentations showing his work, and now he's more focused on the projects that I think from the guys that gave him the money to create a very big institution and so on. So, but I think you should look into his mathematics, because I think you would find him interesting. And it's not your mathematics, but I think you can take some of it and interpret it it from your point of view, I think it would be interesting, because he also looks to the ancient sites and so on. That's how he found his theory. But his is already, he even won mathematical awards, but he's not spoken at all because it's something they don't want to include in current physics, although he's considered the best physician in the world.
Yeah, no, it's interesting how the infrastructure of the academic community is really set up to prevent people from going outside the academic institute to do their research and even talk. I think that's taking away of science. Like, everybody loves their silos. The mathematician only talks to a mathematician, etc. Just look at Newton, or not Newton. Let's look at Charles Darwin. I love Charles Darwin. He's a physician. Now, he's a trained physician, but he published The Evolution and is a naturalist. Everybody knows him as a naturalist because that's what he published as. But he's a trained physician who decided he wanted to change his career without formal training. You can't do that anymore. And so speaking out loud about things that you weren't formally trained on is it's sad, because you're creating an environment that only institutes self-perpetual support of what already exists. There's a great YouTube video, I forget the name of the person. He says most of the great discoveries and innovations come from people outside the field. Yes. Like I presented a presentation to squaring a circle to a mathematician, and he goes, "Oh, I never even thought of that because that goes against my training."
Exactly.
But it makes complete sense. But getting outside perspectives, building a team of expertise of different areas, and being able to share with everybody to see who else has the same passion and inspiration. And yes, there might be people who don't have it formalized in academic publication, but I've read a lot of books that, if you're a trained scientist, in my opinion, you don't throw the baby away with the bathwater.
Exactly.
So I look and study at a book, and there's needles in the haystack. And if you're a trained scientist, you'll be able to see the needles versus a piece of hay. So you take that needle and then build upon all the other needles and all the other haystacks to build a solid mathematical formula or theme. So this is the inability to share it outside the academic infrastructure, I think, is not the most desirable, but it fits the confines of the infrastructure.
Yeah, I think that is lots of problems with science today. For instance, the drawer effect, where they can put in the drawer all the negative results and just publish. And they have 100 tests and only one of them give positive. They are allowed to publish that positive as the only one they've got. So everything else goes into the drawer. That's why it's called the drawer effect. As an example, I can give you this. Some 17 years ago, I went to my government and told them, look, I've been collecting all these books. I'm now around 300,000. I've been collecting all these books and academic data that I think would be most useful for people to have, for students, for teachers to create classes, from workshops to help the elderly, for instance, learning and doing some kinds of works like hieroglyphs and create craftsmanship with ancient knowledge and so on. And you know what they told me from the education department, the top level of the education department told me exactly these words, but in Portuguese. And they were, our interest is not to increase the cultural level of our citizens, but to reduce it.
Mm. That fits on so many levels to so many leaders who've said that.
So what do you say after this? Right?
Yeah.
And that same person would go and make speeches on the beginning of the class that my teachers, or of the schools that my daughters were attending, and they are all for the education and all for the children. And she completely forgot she had just said those words to me a couple of months before, that their interest is to lower the cultural level of people and not to increase it. So
yeah, but that would fit with history. You look at, for example, the Julian calendar, which I think is a misinterpretation of the ancient calendar system. It's actually a less advanced interpretation, but it makes it simple for the general public. And that calendar was released by Julius Caesar. And 3 years prior to that, unfortunately, he put some ships right up against Alexandrian Library and set them a torch, which burnt down part of the library. Oh, sorry about that. Oh, yeah, we're going to replace your knowledge of time with our own calendar. So it's really interesting when you look at history and the destruction of knowledge and the replacement of knowledge with simpler systems, how it is, as you say, they're looking at simplifying things, not making it more.
Coincidence takes planning, because it all looks it just happened, but it in truth is not really like that. Stephen, would you like to add something? You want to share anything? Or you want to promote anything of your work?
I'm happy to have conversations with people. So if it's one-on-one, if people read my work and want to learn more about it, scientists who want to study and formalize it more, mathematicians, physicists, I'm more than happy to do that. I know that there's gaps. I know those gaps have to be addressed in a scientific, rigorous way. And I'm looking forward to doing that. It's a lot faster in collaboration than alone. So I'm hoping that people reach out.
Excellent. I would suggest that when you have the time to read our paper from the Institute, that's called, my memory is so good, I don't even know my own paper, but it's called Statement of Significance for the Global Hallmarks. I can send you the link from the academia site, and you'll find many markers on these buildings that you probably are not including on your mathematics, and it would be interesting to see if you can find relations between the distribution of these hallmarks through the structures and gain a new level of decoding from these ancient sites. That's also we are expecting something that we are expecting the AI does, because it's quite complex to look at their positioning and so on and try to figure it out. What can I make with it? But since you have a mathematical mind specialized in geometry, I think it would be interesting for you to take notice of these hallmarks and start incorporating them on your own research. I think would be fine.
No, thank you.
Well, I thank you very much, Stephen, for being at the Institute for Natural Philosophy. It was an amazing conversation, quite surprising. I was not sure what to expect, just expecting good things, and they came through. So thank you very much for being with us. And to all those that stayed to the end, a very fond farewell to you all. Thank you very much.
Thank you very much for the invitation.
Thank you, Steve.
It was a pleasure. Thank you.